For this video, we're going to investigate how we do integration by substitution to find the value of an integral. So we're given this integral here. We've been asked to integrate the function x multiplied by square root of x squared plus 1 with respect to x between the limits x equals 0 and x is equal to 2. Now, this isn't a function we can just integrate immediately. The square root term is what's causing the problem. We could try integrating by parts, but that's only going to get us into even more of a mess. You can try it for yourself, but we won't actually get anywhere using integration by parts. So we're going to try an integration by substitution. And we can kind of see integration by substitution is going to work because what we need to spot is some function within our integral which will differentiate to give another function in our integral. And we've kind of got two functions here. We have x and we have this x squared plus 1. We do have this other function, the square root, but I'm just looking at the functions, just the x squared plus 1 and the x. If I differentiate x, I get 1. It's not what we've got here. If I differentiate x squared plus 1, I'll get 2x, which is almost what we've got here, give or take that 2 out the front. So that tells me it's probably going to be a substitution that we need to do. So let's try it. What you'll find in real life situations is you have to try different methods to solve an integral. Sometimes you'll try substitution and it won't work. Sometimes you have to do integration by parts. Sometimes you have to do a mixture of the two. It's just a bit of trial and error. So let's try substitution here. In substitution, we pick one of the functions to call it another letter. Typically we use u, but you can use whatever letter you like. So I'm going to say let u be equal to x squared plus 1. Remember, I've chosen that because that's the function that when I differentiate it, it gives me almost this one on the outside. So I've let u equal x squared plus 1. Our next step is to differentiate that with respect to x. So we find du by dx, which, as we've just said, is equal to 2x. Now, the point of doing this substitution is to replace all the x's in our integral, replace them with u's, and keep our fingers crossed that it will give us an integral that we can do. So, I can replace this x squared plus 1 with my u. But I've still got an x here and I've got my dx. Your dx needs to change too. You need to change that into a du. So the way to do that, or the way I'm going to do it anyway, is to rearrange this derivative for dx. So then I can replace that dx with what I find. So let's rearrange for dx. Well, I'm going to take the dx up to this side, up to the right, so I'll get that du is equal to 2x dx. And therefore, if I divide both sides by 2x, I've found my value of dx. Strictly, mathematically, we shouldn't really be doing it in this way. You can't really separate your du and your dx up in such a way, but it works, and that's the way we generally do it. So, let's swap in everything we've got. We've replaced our dx now with a du over 2x. I've swapped my x squared plus 1 for u. Dx is now du over 2x. Let's see what happens. Well, the x's have cancelled here and here, which is really good. we've got no more x's inside our integral here. But are there any more x's here that we can't see? Well, if you think back to what I said at the very beginning, when I read this integral out, it was the integral of x root x squared plus 1 with respect to x between the limit x equals 0 and x equals 2. When you do a substitution, you also have to change your limits. These are actually x is equal to 2 and x is equal to 0. And so these need to be changed into u's as well. So what we say is when x is equal to 2, our u is equal to x squared, so it would be 2 squared plus 1. Well, 2 squared is 4, 4 plus 1 is 5. And when x is 0, I get that u is 0 squared plus 1. Well, 0 squared is 0, so 0 plus 1 is 1. So I've actually got two new limits, but this time they're in terms of u. And once I've changed them as well, then everything in that integral has been changed into u's. So 0 is now 1, 2 is now 5, the x's have cancelled. I've got this factor of a half here, this du over 2 is the same as a half, so I'm going to bring that half out the front of my integral sign. And what will that leave me with? It will leave me with root u du. Now this is certainly an integral we can do now. To solve it, I'm going to rewrite the square root of u. You should remember for your laws of powers and indices that the square root is just a power of a half. So let's put that in there instead. So we're going to have a half, the integral from 1 to 5, u to the half du. We can now do this integration. Remember, when we're integrating just powers, add 1 to the power, divide by the new power. So what are we going to get here? We've got a half. I'm now putting in square brackets with our limits on. It will be u to the half plus 1, so that's 3 over 2. And then I divide by my new power, so I'm going to divide by 3 over 2. Now a good thing to remember when we're dividing by a fraction, if we have 1 divided by 3 over 2, we can basically just flip that fraction over. So 1 over 3 over 2 is just 2 over 3. And that just tidies this up a little bit for us. So I'm going to rewrite that. I'm going to write it as a half 2 over 3 u to the 3 over 2. Don't forget, of course, your limits. We now just need to substitute these limits in. So we'll have a half, and then we'll have a bracket. We substitute the 5 in, so it will be 2/3 multiplied by 5 to the 3 over 2. Upper limit minus what we get when we put our lower limit in. So that will be minus 2/3 multiplied by 1 to the 3 over 2. All we need to do now is tidy this up. So we can see both terms have got a 2 over 3. So I'm going to bring that out the front. So I'm going to end up with a half times 2 over 3. Well, a half times 2 over 3, well, the 2 and the half cancel to leave me with just 1 over 3. So I'm going to have 1/3. And then within my bracket I've got 5 to the 3 over 2. And then I have 1 to the 3 over 2. But 1 to any power is just 1. So I'm going to have a minus 1 there. I'm going to leave my answer here. This answer is exact. It can't really be written any other way. We could rewrite 5 to the power of 3 over 2 as 5 times root 5 if we wanted to. But I think this answer is fine. So that's it. That's our answer. That is this value of this integral here. Remember, when you've got limits, there's no constant of integration, so you don't need to add a plus c. You only need to do that when you don't have limits. But we have limits, so we don't. Thank you for watching.